October 27th, 1962. The Sargasso Sea. We are 300 feet beneath the surface of the Atlantic, inside the pressure hull of Soviet submarine B-59. The air inside does not smell like the ocean. It smells of unwashed bodies, diesel fumes, and fear. The ventilation system has failed. The temperature inside the command center has climbed to 110 degrees Fahrenheit. Carbon dioxide levels are critical. Men are fainting at their posts, their vision tunneling as the oxygen runs thin. Above them, the surface of the ocean is churning. A United States task group led by the aircraft carrier Randolph is dropping practice depth charges. They are grenade-sized explosives, designed to signal, not to kill. But inside the steel coffin of B-59, the acoustics are terrifying. To the crew, it sounds like the hammer of God hitting the hull. They are cut off from Moscow. They are exhausted, and they are convinced that World War III has already begun. We're going to blast them now. We will die, but we will sink them all. We will not become the shame of the fleet. That was Captain Valentin Savitsky. His hand is hovering over the key that launches the special weapon, a T-50 torpedo tipped with a 10-kiloton nuclear warhead. He believes he is cornered. He believes he has been caught by bad luck. But Captain Savitsky is wrong. He wasn't found by luck. And he wasn't found by radar. He is trapped in this situation because of a secret that the United States Navy has been guarding for nearly 20 years. Savitsky thinks the ocean is a cloak of darkness, a place where a submarine can vanish. But he doesn't know that the Americans have turned the Atlantic Ocean into a glass aquarium. For 4 decades, the Soviet Navy operated under a fatal assumption. They believed that the deep ocean was opaque. They believed that if they dove deep enough, they were invisible. They were wrong. While the Soviets built more submarines, the Americans did something far more ambitious. They didn't just build weapons. They weaponized oceanography itself. They wired the seabed with a sensor grid so vast, so sensitive, and so secret that it constituted a God mode for naval warfare. This is the story of the Acoustic Panopticon. This is the story of how the United States turned the physics of sound into a trap that the Soviet Union never saw coming.
Welcome to the edge of the impossible. This is Apex Engineering.
To understand how you wire an ocean, we have to go back to a time when the underwater world was deaf and blind. 1944, the height of the Battle of the Atlantic. At this point in history, hunting a submarine was an act of frustration. Sonar, or sound navigation and ranging, was a primitive tool. It relied on spherical spreading. If you made a noise, the energy radiated outward in all directions, like a light bulb in a foggy room. It got weaker and weaker until it dissolved into the background noise of the sea. Detection ranges were measured in thousands of yards, rarely miles. The ocean absorbs sound energy rapidly. The ocean was viewed as a chaotic mess. It was noisy, full of scattering layers, thermal pockets, and surface interference. The prevailing wisdom was that long-range listening was physically impossible. The laws of physics seemed to forbid it. But on board a small sailing vessel called the Saluda, operating off the coast of the Bahamas, a geophysicist named Maurice Ewing was about to prove the laws of physics wrong. Ewing wasn't a soldier, he was a scientist. He was looking at the ocean not as a battlefield, but as a layered medium. He knew that the speed of sound in water is not constant. It changes based on temperature, salinity, and pressure. And here is the paradox that changed history. In the upper ocean, the sun warms the water. As you go deeper, the water gets colder. Cold water slows sound down. So in the top layers, sound waves curve downward, seeking the slower, colder depths. But once you go deep enough, the temperature stops dropping. It hits near freezing and stays there. Under this point, pressure takes over. The crushing weight of the ocean forces water molecules closer together, and under high pressure, sound speeds up. Temperature decreases sound speed. Pressure increases sound speed. The two forces work in opposition. Ewing realized that somewhere in the middle, trapped between the warm surface and the crushed bottom, there had to be a sweet spot, a specific depth where the speed of sound was at its absolute minimum. He theorized that this depth would act like a lens. Any sound wave trying to escape up toward the surface would be bent back down by the temperature. Any sound wave trying to escape down toward the bottom would be bent back up by the pressure. It was a natural waveguide, a fiber optic cable made of water. Spring 1944, Ewing and his colleague J. Lamar Wurzel decide to test the theory. They sail the Saluda into the deep Atlantic. They lower a hydrophone, an underwater microphone, down to this theoretical channel axis, about 1,000 meters deep. Then, a second Navy vessel sails away. It sails 10 miles, 20 miles, 50 miles. It keeps going until it is literally over the horizon. At specific intervals, the second ship drops a small charge of TNT, 4 pounds, a tiny explosion in a massive ocean. On the surface, that explosion would be inaudible from 10 miles away. The energy would scatter into the air and the waves. But down in the channel, Ewing was waiting. The signal received was unique. Unlike the sharp crack of a nearby explosion, the transmission arrived as a symphony of pulses. Because the sound was trapped in the channel, it didn't dissipate, it focused. The sound waves traveling the straightest line arrived last, creating a building crescendo, a drum roll of noise that terminated in a sharp, high-intensity shock. They called it the SOFAR finale. And they didn't just hear it from 50 miles away. Listening stations in Dakar, West Africa, 3,000 miles across the Atlantic basin, detected the pulse from that 4-pound explosion. Let that sink in. A 4-pound explosion, detected across 3,000 miles of ocean. The implications were terrifying. If you could hear a small explosion from Africa to America, what else could you hear? Could you hear a propeller? Could you hear a generator? Could you hear the mechanical heartbeat of a Soviet submarine? The physics hack was confirmed. The ocean wasn't opaque, it was transparent. The United States just had to build the ears to listen to it. 1949. The Cold War is freezing over. The Soviet Union detonates its first atomic bomb. The threat is no longer just a naval blockade. It is nuclear annihilation delivered by sea. The U.S. Navy takes Ewing's discovery and launches one of the most secretive and expensive engineering projects in human history. Codename: Project Caesar. The goal was madness. The Navy didn't just want to dip a microphone in the water. They wanted to permanently wire the continental shelves of the Atlantic Ocean. They wanted to build a listening fence that spanned hemispheres. But how do you hide a construction project the size of the interstate highway system? You hide it in plain sight. You call it oceanography. The Navy turned to the only organization on Earth capable of laying cable on a continental scale: AT&T and its manufacturing arm, Western Electric. For the next 20 years, massive cable-laying ships crisscrossed the Atlantic. To Soviet intelligence, these looked like civilian vessels maintaining the global telephone network. And in a way, they were. But the cables they were laying didn't carry phone calls. They carried raw acoustic data from the bottom of the world. They called the system SOSUS, the Sound Surveillance System. It consisted of two parts. First, the wet end. These weren't single microphones. These were massive linear arrays, chains of hydrophones over 1,000 feet long, laid out on the seabed like tripwires. By arranging the microphones in a line, engineers could use a technique called beamforming. By electronically delaying the signals from individual phones, operators could steer the listening beam. It turned the array into an acoustic telescope, filtering out the noise of storms and focusing purely on a specific azimuth. The cables ran from the deep ocean shelf up the continental slope and terminated at the dry end, top-secret shore stations known as NAVFACs, or Naval Facilities. NAVFAC Eleuthera in the Bahamas, NAVFAC Grand Turk, NAVFAC Bermuda, NAVFAC Keflavik in Iceland. To the locals, these were boring research outposts studying whale migration and ocean currents. The personnel inside, formerly known as Ocean Systems Technicians, were forbidden to telling their wives what they actually did at work. And the work was grueling. Inside the windowless rooms of the NAVFACs, the air smelled of ozone and burning paper. There were no computer screens, not yet. The acoustic data was fed into massive machines called LOFAR writers, low-frequency analysis and recording. A heated stylus would scratch across a moving roll of treated paper, burning a visual representation of the sound into the sheet. This was the LOFARgram. Operators didn't just listen, they watched the noise. They would spend 8-hour shifts staring at the scrolling paper, looking for the lines. Random ocean noise, waves, shrimp, rain, appeared as a fuzzy gray wash. But a machine has a rhythm. A generator spins at 60 cycles per second. A propeller turns at a specific RPM. On the paper, these mechanical sounds appeared as distinct, solid vertical lines, a fingerprint of man-made order in the chaos of nature. We called it walking the beams. An operator would walk down a row of recorders, scanning the paper for the signature. If you saw the line, you had a contact. And the most important contacts were found in one specific place. The geography of the Cold War gave the United States a massive advantage. To get their submarines from the Kola Peninsula into the Atlantic, the Soviet Northern Fleet had to pass through a specific choke point, the gap between Greenland, Iceland, and the United Kingdom, the GIUK Gap. Project Caesar turned this gap into a trap. They laid arrays directly across the transit lanes. A Soviet submarine commander leaving Murmansk would feel safe. He would look at his charts, see deep water, and assume he was hidden. But the moment he crossed that invisible line, the stylus and Iceland would start burning a black line onto the paper. He was tagged, he was tracked, and he was being hunted. But the Soviets didn't know that. They continued to pour billions of rubles into their submarine fleet, convinced they were building silent killers. They didn't realize they were building loud, clumsy targets that were broadcasting their position to the enemy before they even left home waters. And in October 1962, that ignorance would nearly cost them everything.
Back in the Caribbean, inside submarine B-59, the air is running out. Captain Savitsky screams that the war has started. He orders the nuclear torpedo to be armed. The political officer agrees. They are seconds away from vaporizing the U.S. task force above them and likely starting a nuclear holocaust that would incinerate the Northern Hemisphere. But here is the detail that history books often miss. Savitsky felt cornered because he was cornered. He thought he had slipped into the Atlantic like a ghost, but the moment his submarine and 3 others from the 69th Brigade crossed the Iceland-GIUK Gap weeks earlier, a stylus in a windowless room thousands of miles away began to twitch. The system provided God mode visibility. We weren't searching for them blindly. We knew their address. The U.S. Navy didn't have to patrol millions of square miles of empty ocean. SOSUS operators watched the spectral lines of the Soviet engines move south on their paper charts. They handed the general coordinates to the fleet. They simply picked up the phone and told the destroyers where to go. The Soviet captains were bewildered. Every time they raised a snorkel to charge their batteries, an American P-2 Neptune patrol plane was overhead. Every time they tried to sprint, a destroyer was waiting to ping them. This is the operational test of Project Caesar, and it worked too well. It created a tactical pressure cooker that broke the psychological state of the Soviet commanders. They weren't just being hunted, they were being suffocated by an enemy that seemed to know their every move before they made it. On B-59, only the intervention of the flotilla commander, Vasily Arkhipov, stopped the launch. He realized the Americans were signaling, not attacking. He forced the sub to surface. We rightly hail Arkhipov as the man who saved the world, but we must understand the engineering context. The SOSUS network stripped the Soviet Navy of its stealth. It forced a diesel submarine into a confrontation it could not win, creating the most dangerous moment in human history. The crisis ended. The world exhaled. But Project Caesar didn't stop. In fact, after 1962, the system evolved. It stopped being just a tripwire for war. It became something far darker. It became a planetary black box, a tape recorder that was always running, capturing the death screams of lost ships.
April 10, 1963, 6 months after the missile crisis. The USS Thresher, the most advanced attack submarine in the American arsenal, is conducting deep diving tests off the coast of New England. At 9:13 a.m., the surface escort receives a garbled message. Experiencing minor difficulties, attempting to blow. Then, silence. On the surface, the panic was immediate. Ships and aircraft scrambled to find the sub. But hundreds of miles away, at SOSUS stations in Nova Scotia and Antigua, the operators already knew the truth. They didn't need to search. They just had to rewind the tape. This brings us to the most chilling application of the Acoustic Panopticon: forensic acoustics. Bruce Rule, the Navy's lead acoustic analyst, didn't just hear a noise.
He dissected the physics of a disaster frame by frame. Looking at the LOFARgram, Rule could see the timeline of death written in frequency lines. First, at 9:09 a.m., a wobble in the electrical frequency. The main coolant pumps tripped offline. Then, the sound of the reactor scramming, shutting down. The submarine loses propulsion. It begins to sink. Then the hiss of high-pressure air. The crew is trying to emergency blow the ballast tanks, forcing air in to push water out. But the hiss cuts out. The airlines have frozen. The physics of expanding gas, adiabatic cooling, blocked the pipes with ice. The Thresher is now a heavy stone, falling past its crush depth. And then at exactly 9:18:24, the event. SOSUS sensors recorded a high-energy, low-frequency pulse. It wasn't an explosion, it was an implosion. When the pressure hull failed at 2,400 feet, the ocean rushed in at supersonic speed. The air inside the sub was compressed from a large volume to a tiny bubble in milliseconds. This compression created a massive flash of heat, hotter than the surface of the sun for a fraction of a second, and a shockwave equivalent to 22,000 pounds of TNT. We call it the bubble pulse. The ocean collapses, bounces back, and collapses again. It is a distinctive acoustic signature. It sounds like the end. Because of SOSUS, the Navy didn't have to guess. They knew exactly when the Thresher died, and by triangulating the signal arrival times at different stations, they knew exactly where she died. They found the wreck not by looking, but by listening. But 5 years later, this forensic capability would give the United States one of the greatest intelligence prizes of the Cold War. March 1968, the North Pacific. A Soviet ballistic missile submarine, K-129, vanishes. The Soviet Navy launches a massive rescue fleet. Dozens of ships, hundreds of sorties. They scour the Pacific for weeks, but they are looking in the wrong place. They are blind. Eventually, Moscow gives up. They declare the boat lost with all hands. They assume the ocean has swallowed their secrets. But the Americans were watching the Soviet search effort. They realized a sub was missing. So, they did what they always did. They checked the SOSUS tapes. They found it. On March 8th, sensors at NAVFAC-ADAC in Alaska and NAVFAC Point Seward in California had triangulated a catastrophic acoustic event, a bang. The triangulation was precise within 5 nautical miles. We knew the address. 1,560 miles northwest of Hawaii. Depth, 16,500 feet. Think about the disparity here. The Soviet Union could not find their own submarine. The United States knew its location within 5 miles. This knowledge enabled the CIA to launch Project Azorian. They built a massive ship, the Hughes Glomar Explorer, pretending to be deep-sea miners. In reality, it was a giant claw designed to reach down 3 miles and steal the K-129. They recovered nuclear torpedoes. They recovered code books. They recovered the bodies of Soviet sailors. By the late 1960s, the victory was total. The Atlantic was wired. The Pacific was monitored. The U.S. Navy could track the enemy in real time and locate their wrecks with forensic precision. The Soviet Navy was naked. And the terrifying part, they didn't know it. They still believed their submarines were stealthy. They still believed the game was fair. It would take a betrayal of biblical proportions to break the system. It wouldn't be an engineer who defeated SOSUS. It would be a man named John Walker, walking into an embassy with a bag full of debt and a heart full of resentment. And he was about to turn the lights out on the American century. For over 20 years, the Soviet Union played a game of poker
where their opponent could see every card in their hand. They built hundreds of submarines, assuming they were invisible. They were wrong. But in 1967, that ignorance ended. And it didn't end because of a Soviet breakthrough. It ended because of an American failure. Meet John Anthony Walker. Walker wasn't a communist ideologue. He was a U.S. Navy warrant officer, a communications specialist with high-level clearance, and a man with a failed bar, a failing marriage, and a lot of debt. In December 1967, he walked into the Soviet embassy in Washington, D.C. He didn't offer them weapons. He offered them the keys to the library. For 18 years, the Walker spy ring, which included his brother, his son, and his best friend, funneled over 1 million classified documents to the KGB. History often focuses on the key lists, the daily codes that allowed the Soviets to read encrypted Navy messages. And yes, that was devastating. But the real damage wasn't the text, it was the context. Walker gave the Soviets the why. He handed over operational briefings that revealed the existence and the capability of SOSUS. For the first time, the Soviet Admiralty looked at the documents and realized the terrifying truth. The Americans weren't just lucky. They were listening to the cavitation of Soviet propellers. Let's talk about cavitation. When a propeller spins fast underwater, it creates low-pressure zones on the blade tips. If the pressure drops low enough, the water literally boils. It creates vacuum bubbles. When those bubbles collapse, they snap shut with a violent crack. To a hydrophone, a cavitating propeller doesn't sound like a swoosh. It sounds like a jackhammer. Walker revealed that Soviet subs were cavitating at much lower speeds than they realized. And worse, that this specific frequency was coupling perfectly into the SOFAR channel. They were driving around the ocean with their high beams on. The Soviet reaction was immediate panic. And then, industrial mobilization. They needed quiet propellers. They needed blades so perfectly shaped and polished that they could slice through the water without creating bubbles. But their domestic manufacturing base was too crude. They couldn't build them. So, they cheated. Years later, in one of the most notorious scandals of the Cold War, the Soviets illegally imported 9-axis computer-controlled milling machines from a Japanese company, Toshiba, with software from a Norwegian firm, Kongsberg. These machines allowed the USSR to mill propellers with microscopic precision, technology that was strictly banned from export. They bypassed decades of R&D in a single purchase. The result was the Victor III and the Akula-class submarines. When the first Akula hit the water in the mid-1980s, the alarms at the SOSUS stations didn't go off. The God mode screen went blank. The spectral lines on the LOFARgrams disappeared. The Akula could cross the GIUK Gap in silence. The ocean, which had been transparent for 40 years, suddenly became opaque. The Cold War ended in 1991. The Soviet Union collapsed, not from a torpedo, but from bankruptcy. With the threat of global nuclear war receding, the Navy finally acknowledged the existence of the system. The secret weapon was declassified. But the cables were still there. The hydrophones were still listening to the deep Atlantic. And nature, it turns out, abhors a vacuum. In the 1990s, the Navy did something unprecedented. They gave security clearances to civilian biologists. Scientists from Woods Hole and NOAA were allowed to plug their headphones into the war machine. They discovered that the SOFAR channel wasn't just for submarines. We found that blue and fin whales speak at the exact same frequency,
around 20 hertz. They were using the deep sound channel to communicate across entire ocean basins, just like we feared the Soviets would. The system that was built to track the apocalypse is now used to track the migration of leviathans. It listens for underwater earthquakes. It monitors the health of the planet's crust. The Acoustic Panopticon has become a stethoscope for the Earth itself.
The story of SOSUS is the ultimate paradox of the atomic age. It was a weapon of immense strategic power that never fired a shot. By hacking the physics of the ocean, the United States turned the Atlantic into a trap, forcing a superpower to blink during the Cuban Missile Crisis and allowing the recovery of secrets from the deepest trenches of the Pacific. It proved that in the 20th century, the greatest advantage wasn't firepower, it was information. It was the ability to see the enemy when the enemy believed they were hidden. But it also serves as a warning. The system wasn't defeated by a better engineer. It wasn't defeated by a smarter physicist. It was defeated by a single human being who felt undervalued. All the concrete, all the cable, and all the billions of dollars could not protect the United States from the simple, fragile nature of trust. The ocean is silent again. The God mode is gone. But while the Americans were scrambling to fix the damage caused by the Walker spy ring, deep in the frozen shipyards of Severodvinsk, the Soviets were already welding the hull of something new. They realized they could no longer hide in the noise, so they decided to build a monster so large it didn't need to hide. A submarine twice the size of anything the world had ever seen. A steel leviathan that could destroy the world without ever leaving its own pier. But that is a story for another time.